By the year 2325, Mercury's solar collection area had reached a staggering 20 million square kilometers, with a total power output of 40 petawatts. Humanity has entered the realm of a Type 1 civilization. And yet, against the demands of our future, it was barely a drop in the ocean. Soon we pushed Mercury even further. By mining just the shallow crust of the planet's surface, we harvested enough material to construct a solar ring in mercurial orbit, 1,100 kilometers wide. Nearly every step of the construction was carried out autonomously by self-replicating building units. Each unit linked to its neighbors through electromagnetic induction, forming a flexible, soft connection, allowing every segment of each ring to remain in relative stillness. The ring was extraordinarily thin and light. Every gram of its material was sourced from Mercury itself, and it could continuously adjust its own orbit to keep its face turned permanently toward the Sun. The full structure was subdivided into thousands of narrower sub-rings, each rotating at a different orbital altitude to balance the gravitational pull of Mercury and the Sun. The result was astronomical, spanning nearly 20 million square kilometers, equal to Mercury's own sunlit cross-section. With 3 of these rings, Mercury delivered 160 petawatts of energy, 4 times the output of a Type 1 civilization, and more than enough to power humanity's next great leap. To deliver this immense energy across the solar system, we must convert it into its purest possible form: photons.
Photons are perfect energy carriers. They are stable, fast, and naturally suited for traveling through the vacuum of space. Most importantly, the higher their frequency, the greater their energy. There is only one problem. Diffused photons, like sunlight, will easily scatter and fade into the vacuum of space.
To power an interplanetary civilization, we must concentrate that energy into something far more precise. On the far side of the golden record, humanity has built another colossal structure. This is the beating heart of the solar system's energy grid. The electrical current generated by the solar rings converges here, inside these conversion stations. Ultra-high voltages accelerate electrons to near the speed of light, then slam them into heavy target plates, converting raw electrical power into 100 mega-electron-volt gamma-ray photons. All the energy Mercury produces is compressed into these stations. Each beam carries 8 petawatts of power, more powerful than the biggest hydroelectric dam on Earth by 350,000 times. When Mercury ignites, the entire solar system will tremble. This beam of unimaginable power will cast the colossal energy of Mercury to every corner of the solar system. Gamma-ray photons travel at the speed of light in a fixed direction, which means they cannot be detected before they arrive. Humanity must build layer upon layer of safeguards around every single being. Before each burst of gamma energy is fired, Mercury must first send out a visible warning light along the same path. These precursor beams act as the supercables of the solar system, marking the energy highways. and the absolute no-fly zones. Beyond warning passing spacecraft, these visible light paths also serve as precision guides for the energy transmissions that follow. To minimize error, the travel distance of each beam segment must be kept as short as possible, because even a deviation of 1,000th of a degree, amplified over millions of kilometers, means catastrophe. To achieve this, relay stations must be positioned throughout the solar system. Each node makes constant precision adjustments to its alignment with the others, ensuring that a gamma stream fired hours earlier arrives exactly where it is meant to. If a gamma beam fails to reach its receiving station on schedule, it does not simply vanish. It keeps going, tearing through deep space, a searing column of pale plasma, annihilating everything in its path into ionized vapor. Or perhaps it could be observed by an alien civilization hundreds of light years away. These runaway gamma beams would blaze with the intensity of a supernova. And yet their spectrum would be far too clean, too uniform, to be mistaken for anything natural. Even if the beam arrives at its destination, the challenge is only half complete. Gamma rays carry energy too violent, too destructive to be used directly. But there is good news. Gamma radiation can be broken down and converted. The technique is known as the gamma cascade. A gamma-ray photon is torn apart by the electric field of an excited atomic nucleus, splitting into a matched pair of particles. One electron, one positron. They would have annihilated each other in an instant. But guided by ultra-intense toroidal magnetic fields, the particles are elegantly separated. Positrons swept toward one collector, electrons toward the other. A final force field converts their momentum into usable voltage, with an overall energy conversion efficiency of up to 99%. No roar of heat engines, no spinning turbines. This is energy conversion in its purest form. Build a receiving station in the right place, and this energy can reach every corner of the solar system. The diffuse sunlight that has bathed the solar system for 5 billion years can now be gathered, focused, and delivered as directed beams to every planet, powering industry, fueling economies, driving civilization forward. From this moment on, humanity becomes a civilization that feeds on life.